Hello dear students, welcome back to the NEET Physics Crash Course 2026. In this lecture, that is lecture 5, we will cover integration. As you all know that we have already covered the topics differentiation, trigonometry, coordinate geometry, slope, graphs, algebra. So in this lecture, we will cover integration, and this is very important as far as physics is concerned, because in the complete mechanics section, in the complete thermodynamics section, thermodynamics, in heat section, in electrodynamics, everywhere you will find use of this integration as well as differentiation that we have covered in lecture 4. So without losing any time, let's start integration. So the very first thing we have to understand it, why do we need integration? So let us understand with some examples. Now suppose I draw a rectangle and I ask you to find its area. You can easily find its area using the standard formula, that is length into width. Now if I draw a circle, and you ask you to find its area, then pi r square is its area, you can easily find. And if I draw a rectangle, then again you can easily find its area by using the formula half base into heights. So these are the regular figures where you have the standard formula for each of these figures for its area, isn't it? So different figures have different formula for area. But if I draw any irregular figure like this one, and I say find area, suppose this point is B, C, D, and if I say find area A, B, C, D, A, so you don't have, since this is not a regular figure, so you don't have any standard formula to find its area. So here comes the rule of integration, isn't it? Now while writing the area, you must know the sequence how we write. We have started from point A, that is point A, B, C, D. So from D, where you are going, I mean from D to somewhere else, or again coming to A. So you must write the area, name of the area, in such way the opening and closing point must be same. Only then the area will be closed, that figure will be closed, and only then you will be able to find its area. So this is how we write A, B, C, D, A, that is A, B, C, D, A. So this figure, we have to find the area of this closed figure. That's why I again put A here, because some students ask, sir, why are you put A here, isn't it? So this is the method. So now we have to find the area of irregular figure, and for this we need integration. So what is the procedure? Let's see step by step. So the very first thing is, let us suppose this is y-axis, this is x-axis, and if I plot, this is a graph, and suppose I wish to find this area. Suppose I wish to find this area, that is the area being A, this point is A, B, C, D, A. So I wish to find area A, B, C, D, A. This is how we write. So which area we need to find? I'm going to shade those areas. I'm going to shade the required area which I wish to find, this area. So it must be very clear to you. So I wish to find this shaded area, that is area A, B, C, D, A. Now what is the procedure, dear students? So first of all, seeing the procedure, let's complete the figure first. Isn't it? So name it as A, B, C, D. Let us suppose this point here, the value of x is x1. This point is A, no doubt. This point is A, this point is D. But here the value of x is x1, and here the value of x is x2. This is x-axis definitely, and this is y-axis. So the step number 1, to find the area A, B, C, D, A, that is to find the shaded area, first we take elementary strip of infinitesimal small width, isn't it? So take elementary strip of infinitesimal small width, very small width. So I'm taking it. Let us suppose this is the elementary strip, very small, and the gap between this elementary strip, this gap, that is width of this elementary strip, is given by dx. Now if I take a point in between, I name this point as p, isn't it? Now there are two more points, there are two more points here and here where the length line of this strip touches the curve. So I am taking these 2 points as, let us suppose this is point q and this one is point r, this is point s and this point is t. So here we have the elementary strip qrst, qrst, where this point p lies in the center of the portion covered by the strip, isn't it? Now what is the y coordinate of p? So if I mark it as, here is the ruler, so suppose I join this, suppose I join this, so this distance, so this is y, so this length, that is height of p from x axis, is y, isn't it? So the very first step is we have to take the elementary strip having infinitesimal small width dx. This is the first step. And in this step we have marked the vertices, that is r q t s, and the center of this portion of the curve which comes under the this elementary strip is taken as point p, isn't it? So what happens, dear students, if I zoom it, if I zoom this elementary strip, then understand very carefully what happens when I zoom in. So first of all, the very first question you may ask that, sir, why we have taken this elementary strip with very small width, isn't it? So the logic says, as we have done in lecture 4 in differentiation, so the logic is, if we take this elementary strip's width very small, then the portion of the curve QR will appear as a straight line, and this is what we want to have, that this portion, that is QR portion, must be straight. So we take the length width of this elementary strip as very small, so that this portion QR of the curve appears as a straight line. So the if I zoom it, if I zoom it, so the figure would be like, so this is, so this is the actual procedure. We are understanding a very core concept of integration. So you must have patience, dear students. Only then you will be able. If you scroll this part, then you don't get the core concept of integration. That why do we need integration and what is the procedure to find integral values, or how it is equal to the area under the curve. So keep patience and just observe the procedure. So if I zoom it, then what happens? What happens? Suppose, so this is point T, this point is Q, this is point R, and this point is S, and in center here we have point P. So this is point P, this is point P. Now this is the step number 1, we take elementary strip. Step 2, we have to find the area of this elementary strip. So what is the area of this elementary strip? So observe carefully. Now forget this figure. First of all, we have to focus on the elementary strip. So we have to find the area of elementary strip. So what is the area of elementary strip? So I write area Q R S T Q, Q R S T Q, this area will be area of elementary strip, that is Q R S T Q. This we need to find, isn't it? So here I am doing some arrangements and observe that arrangement. So I am extending this line and join this line. So this is point P. Let us suppose this is point U and this point is point V. Now what happens? This is the turning point of this integration concept. Since this P lies at the midpoint of this section QR, isn't it? So what happens? This triangle, that is triangle PRU and triangle PVQ, are congruent to each other, that they are exactly equal, they are exactly similar. And in maths we say triangle PRU exactly covers the triangle QVP. It means that this length is equal to this length, this side is equal to this side, and this side is equal to this side. Are you getting? So all the sides are equal, all angles are equal. So what we get, the area, this area, what I am saying, observe carefully, the area PRUP, the area PRUP, that is this area, will be equal to area QVPQ, that is this area, because of symmetry, that is area QVPQ. QVPQ. Now are you getting? These two areas are equal. Now if I write, so keep in mind this equation. Now I am writing the area QRSTQ, isn't it? Area QRSTQ. This can be written as area QPUST. This can be written as area QPUST. USTQ plus. So this area QPUSTQ, this area plus about triangle area, that is area PRUP, area PRUP. So total area QRSTQ, that is the area of elementary strip. This is the area of elementary strip, is equal to, can be written as the summation of these two areas. And what happens, this area QPUSTQ, this area QPUSTQ plus, so instead of writing area PRUP, we can also write area PVQP, area PVQP, because these two areas are equal. So this will be area PVQP. Now what happens, if you observe carefully, these two areas, the summation of that is QPUST plus this area, this will form the area of this rectangle. This will form the area of this complete rectangle. Are you getting? That is area TVUST, area TVUST. And what is the height of P? That is, P is at a height of distance y from x-axis. So the area of this rectangle TVUST, we have to find. So this height is given by y. This height is y, isn't it? And the width of this elementary strip is already, we already took it as dx. So area of this elementary strip is given by area of this rectangle, area TVUST, and its area is given by y dx. So this is the step number 2. So first step, we have taken the elementary strip. Second, we have found out the area of elementary strip, that is y dx. Now the third step is very important. So what is the third step? So the third step is, I'm drawing this curve as, I'm drawing the same curve again. So what is the third step? So in third step, what we do? So we take area. So we start taking elementary strips from x is equal to x1. So we take infinite number of small strips and find the area of all strips, and we add the area of all these strips. And if we add the area of all these strips starting from x is equal to x1 to x is equal to x2, then we get the required area which we are interested to find, that is area. So dear friends, if I wish to find this area now, that is area ABCDA, this point is A, this is B, this is C, and this is D. So what we do, we find the area of these elementary strips, that is y dx. Area of this elementary strip is again y dx, because we have found out the area of elementary strip, that becomes y dx, है ना? So remember, what is the area of elementary strips? That is y dx. We have found out, isn't it? So we have find the area of elementary strip is y dx. So the area of each elementary strip will be y dx, and if I add all areas of all the elementary strips, that is y dx, y dx, y dx, y dx, from x is equal to x1. So this is, here the x coordinate is x1 and here the x coordinate is x2. So if I add all y dx starting from x is equal to x1 to x is equal to x2, then we get the total area, that is area ABCDA, isn't it? So I'm writing here area of elementary strip. So what we obtain, that is y dx, and if I write area ABCDA, area ABCDA, ABCDA, this is sum of all elementary strips starting from x is equal to x1 to x is equal to x2. So that sum of all elementary strips is written in maths in the format of this symbol, that is, this symbol is stands for summation. So it means that we are adding y dx from x is equal to x1 to x is equal to x2, and this summation is also written as, so observe carefully, if I write s, then this is s, and if I stress this s vertically, so this will become like this, isn't it? So I write this summation in this format and write y dx, and here I write from x is equal to x1 to x is equal to x2. And my dear friends, this is nothing but integration. This is nothing but integration. So what conclusion we are getting here? That integration is nothing but summation. So what is integration? Integration is accumulation of smaller parts, that is summation. So the slogan of this lecture is integration is nothing but summation. So this is y dx. Are you getting? Area ABCDA is equal to y dx. Now very important point. So I'm going to summarize by taking different examples. Now let us suppose this is y-axis, x-axis, this is x-axis, this is y-axis, and if I plot a curve like this one, isn't it? If I plot a curve like this one, here it is x1 and here it is x2, and if I write, observe carefully, if I write y dx from x1 to x2, so what it does it represent? So it will give area between the y-x curve and the x-axis. Let us have some discussion about terminologies. This x1, this is known as lower limit. This x2 is known as upper limit. So here integration is, y is being integrated with respect to x, isn't it? And this is a symbol of integration. So what is this area between y-x curve and the x-axis? So here, observe carefully, if I put dx, it means there is infinitesimal small change in dx. So change is starting from x1 to x2. These limits are of that variable which are here in the format of dx. Suppose if I write here dz, So the limits will be like z1 to z2. If I write here dy, then limits will be like y1 to y2. I'm writing here dx, so the limits is like x1 to x2. So what isn't it? So this two must be in same variable. If here it is x, then here it is also x. Now it is y dx. It means that we have taken the strip parallel to y axis, and the width of the strip is given by dx. So we have taken the limits from x1 to x2. So this will give area between y x curve and the x axis. Now second case, so this is x axis, this is y axis. Now suppose I am plotting the same figure like this one, but here I am taking y1 and this is y2, isn't it? And if I write x dy, if I write integral x dy, so here I am putting dy, isn't it? So the limits are from y1 to y2. Since this is x dy, so x must be the height of the elementary strip and dy must be the width of that elementary strip. So in this case, if you think carefully, that this strip must be parallel to x axis, isn't it? Here it is y dx, so this strip must be parallel to y axis. Here it is x dy, the strip must be parallel to x axis, and its width is given by dy. So the strip will be like this one. Strip will be like this one, and this is x, and the width of this strip is dy. So area of elementary strip will be x dy, this area. Now if you write x dy, it means that you are adding x dy from y1 to y2. So here I take elementary strip, its area is x dy, this area is x dy, this area is x dy, or integration of x dy, it means that we are adding this x dy from y is equal to y1 to y is equal to y2. So here we are not getting area under the curve. Are you getting now? This is very misconception that a student has. Many students have this misconception. They x dy, they find this area below this curve, this one. But in this case, the area x dy is not area below the curve. Actually, it is this area. Hai na? Are you getting? So from x dy area, if I write x dy, then this is area between. So in this format, if you write, there is, I mean, no misconception will be there. So area between xy curve and the y-axis. Observe carefully. Here it is dy, then the area will be area between this xy curve and the y-axis. So in between these two, this is curve and this is y-axis. In between these two, the area you will get is x dy. What happens here? This is y dx. So this will be area between y-x curve and the, since dx comes here, so this is area between y-x curve and the x-axis. So this is y-x curve and this is x-axis. So integration of y dx, you will get this area. So are you able to understand the difference between the two now? So this is area x, this is the meaning of x dy, and this is the meaning of y dx, isn't it? So the next is integration as the inverse process of differentiation. Now understand, dear students, carefully, that differentiation is the process of breakdown of function into smaller parts, whereas integration is the process of accumulating those smaller parts. That's why we say that integration is the inverse process of differentiation. Now many students ask, sir, what is the meaning of inverse process? So listen, if I take 7, so if I take 6 and if I add 3 to this 6 and subtract the result from 3, so what we get? 6. We have started from 6 and we have reached 6. So the two operations must be inverse of each other, because two operations, when taken in sequence way, they produce no change in the earlier number, isn't it? So these two process, that is these two process, addition, or you can say these two operation, addition and subtraction, are inverse of each other, because we got the same result. So addition and subtraction are inverse of each other. So are you getting now? You have reached the same value from where you have started. Suppose I write 7 into 3 and divided by 3, you get 7. Again, you have started from 7 and finally you have reached 7. It means that this multiplication and division are inverse of each other. So multiplication and division are inverse process of each other. Similarly, what happens now? There is a formula of integration and differentiation. And what is that formula? Suppose if I write remind lecture number 4, dy dx of x to the power n, this is the formula, that is n x to the power n minus 1, implies that what happens, dy dx of, if I wish to find x squared, then this will be, power comes before this expression and power gets reduced by 1, 2 minus 1, so this will be 2x, isn't it? Now in integration we have the very common formula, x to the power n. So its formula is given by x to the power n plus 1 by n plus 1. Here the condition is n is not equal to minus 1. Why? Because if n is minus 1, then minus 1 plus 1 becomes 0 in the denominator, which is undefined in mathematics, isn't it? So suppose if I write, let us take example of integration of 2x, isn't it? So what happens now, as we have learned in differentiation as well, that whenever there is some constant in the multiplication of the variable, that constant comes out of the differentiation. Similarly in integration as well, as if there is a constant in the multiplication of x, that then that constant will come outside and you will integrate x. So here the power of x is nothing, it means its power is 1. So what is the formula? Applying this formula, that is x to the power 1 plus 1 by 1 plus 1, that is x square by 2. So this will be 2x square by 2, and finally we will get x square, isn't it? So observe the sequence. We have started from x square. So we have differentiated. So dear students, we have differentiated this x square. We have differentiated here. We have differentiated. We get 2x, and after integration, we again got x square. So are you getting? We have started from x square and finally we get x square. That's why we say that differentiation and integration are inverse process of each other. So are you getting, dear students? So so this is the logic, isn't it? Now let us suppose if I write dy dx of sine x. So this is cos x, as we have learned in lecture 4. So since integration is the process of inverse process of differentiation, so we have differentiated the sine x and we got the cos x. It means that if we integrate cos x, then we must get sine x. So this is how the formula of integration is being, you can learn this formula by this method, isn't it? So we will have some more formula, but before proceeding to the formula, let us have some look at the very basic concept. Suppose I find its differentiation of expression. So this will be dy dx of x square plus dy dx of 3, and we get, this is 2x and differentiation of constant is 0. So finally we get x square plus 3, differentiation, we get 2x. Are you getting? So this is 2x. So far we have learned that if the differentiation of x square plus 3 is 2x, so since integration is the inverse process of differentiation, it means that integration of 2x must be equal to x square plus 3. So let us find the integration of 2x. And as we have find earlier, this is 2x dx. So this will be 2x square by 2. 2 gets cancelled and we get the value x square. Integration of 2x is x square. But as per the definition, that is integration is the inverse process of differentiation. So on differentiating x square plus 3, we get 2x. So on integrating 2x, we must get the same function, that is x square plus 3. But here this 3 is missing. So to compensate the value 3, we put constant here. And this is very important concept. So whenever you integrate any function, you put constant here, and this is known as, this constant, this is known as constant of integration. This is known as constant of integration. This c may have any value from minus infinity to plus infinity, isn't it? This c may have any value, and in physics there are many numericals where you have to find the value of c by using the limits or the conditions given in the question. So that we will see further, isn't it? So this is constant. So in all the formula where you are finding integration, you must put a constant of integration. This is the logic. So now let us have look at formula. So the formula goes like, The very first formula is differentiation of sine x is cos x. So integration of cos x is equal to sine x, and we put constant of integration. Similarly, differentiation of cos x is equal to minus sine x. So integration of sine x is equal to minus cos x plus c. Isn't it? Differentiation of log x is 1 by x. So integration of 1 by x is equal to log x plus c. Integration of differentiation of tan x is sec square x. So integration of sec square x is equal to tan x. Differentiation of sec x is equal to sec x tan x. So therefore integration of sec x tan x is equal to sec x plus c. Differentiation of e to the power x is equal to e to the power x. Therefore integration of e to the power x is equal to e to the power x plus c. And the most common formula, that x to the power n is given by n plus 1 by n plus 1, provided n is not equal to minus 1. This is the common formula you come across many times in solving the numericals of physics. Now what happens, dear students? Suppose if I write cos ax plus b, so this will be definitely cos function. If I integrate the cos function, that it is converted into sine function. So here that is sine ax plus b. And if it would be differentiation, then we multiply this a with this result, but this is integration, and integration is inverse of differentiation. So we divide this result by a. Similarly, if you write sine ax plus b, so this will be minus cos ax plus b divided by a. Similarly, e to the power ax plus b, so this will be e to the power ax plus b divided by a. So these are the various formulae of integration. So these are sufficient now, isn't it? As far as physics numericals are concerned, only this number of formula are sufficient. So proceed into the next slide, definite and indefinite integral. So dear student, there we define integral in two ways, isn't it? The first is definite integral. So as far as definite integral is concerned, definite integral, so what are the features of definite integral? So this definite integral, as you so this definite integral having two features, that is they have limits. And remember, when we have learned about the graph, then we put lower limit and upper limit, isn't it? And they don't have constant of integration, that is c, constant of integration. Okay, isn't it? So no constant of integration. Now, whereas if we talk about indefinite integral, as its name suggests, indefinite, so its value is not fixed. So what happens here? Constant of integration exists, but limits don't exist. Therefore, this indefinite integral is not having fixed value, because this c may have any value, but since this indefinite integral doesn't have limits, so its value is not fixed. That's why it is known as indefinite integral, isn't it? So for example, if I write x square, so its value is given by x cube by 3 plus c. Are you getting? So this c may have any value, isn't it? So this we don't know its value until some boundary conditions are not given. So we cannot say that this I mean whatever we obtain from x integrating x square, we are not getting a fixed value. This value is not fixed. Its value depends on c, and this c may have any value. This c depends on the physical conditions, boundary conditions, the question of the questions or of the situations given in the questions. So this is not having fixed value. That's why we say that without limits, this integral is without limits. That's why we say that this is indefinite integral. Now suppose if I put limit here, suppose from 1 to 2, then what happens? The steps to solve this is we integrate it x cube by 3, and as we know here c comes, so we put lower limit, upper limit. Now the next step is, in the place of x we put upper limit and write the expression as it is, isn't it? So in place of x I'm writing upper limit 2, then all the things will remain as it is, that is in the place of power we put 3, in denominator we put 3 here plus c, and just close the bracket, and after that put minus sign, and again in place of x put the lower limit and remain all the expression as it is, isn't it? So this will be 1 cube by 3 plus c. So what happens, this will be 2 cube minus 1 cube by 3 plus c minus c by 3. This c gets cancelled, and finally we get this will be 7 by 3. Now this limit, this integral is having a fixed value, that is 7 by 3. That's why its value is fixed, or you can say definite. That's why this is known as definite integral. So always the integral with limits are known as definite integral, and you don't need to constant of integration in this definite integral, because ultimately they get cancelled, isn't it? And in indefinite integral this limit value is not fixed. That's why it is called so. So application, so very important in physics. What is the application of integration? So always remember, the very first application is, suppose we need to find work done, isn't it? So first application, that is work done by variable force. Work done by variable force. Variable force means the force depends on the position of the particle. So let us suppose, so we're done here. So we have the formula f dx from x is equal to x1 to x2. So this is very important formula, dear students. So this is the formula of work done. Now this is in the format of integral y dx. In place of y we have force here, and in place of x we have x, that is displacement. So if I plot a graph like this one, this is force axis and this is representing displacement, and if I write here, so let us suppose this is force, this is representing force in Newton, and this is representing, you can write x, that is displacement, and it is in meter. So what happens if the curve of force with displacement is like this one? Force is being represented by this line, and you are asked to find the work done. Find work done in displacing the object, in displacing the object from x is equal to 2 meter to x is equal to 4 meter. Are you getting? So there are these values are given in the question. In question these values are given. So this is this graph is given in the question, and the curve, that is y-axis, here we have force, and in x-axis we have displacement, and you have to find the work done for in displacing the object from x is equal to 2 meter to 4 meter. So as we know, w is equal to integral f dx, है ना? And what is being represented by this f dx? So this f dx is nothing but, actually this f dx, this w is equal to f dx from x1 to x2. This is nothing but area between fx curve, area between fx curve and the x-axis, isn't it? So ultimately we have to find the area. So there are many questions which come in NEET where you are given the graph and find the area, find the slope. So if you don't know, you have misconception regarding this slope and area under the curve, that is in differentiation and integration topics of basic maths, then you will not be able to solve such kinds of questions. So you have ultimately, this question is very easy. It hardly takes 30 to 40 seconds to find the answer, isn't it? So what is work done? That is area between this force x curve, that is this curve, isn't it? So area between this curve and the x-axis, but the limit is from x is equal to 2 meter to 4 meter. So this area we need to find, this area we need to find, and this is the work. So to find this area, I am marking it A, B, C, D. So this area is given by area of, and observe carefully, this figure is forming a trapezium. This figure is forming a trapezium. So this is A, B, C, D. Now if I write the shape of the figure, that is trapezium, then we don't need to put A again there, isn't it? If A, B, C, D, A, B, C, D, trapezium is completed. So the communication gets completed if I put trapezium. Suppose if I don't write trapezium, then I need to write A, B, C, D, A. So that we are saying that we are taking the area A, B, C, D, and from D we again come to A. But if I put the shape of the figure trapezium, then this last A can be ignored, isn't it? So what is area of trapezium? This is half sum of the parallel sides multiplied by height. So sum of the parallel sides means AB plus CD. So this AB and CD are parallel. So this is AB plus CD multiplied by height. Height means the distance between the parallel sides, that is given by AD. So this will be half. What is AB is 20, what is CD is 60, and what is AD, this is 4 minus 2. So this value is 2, isn't it? So this is 2. So this 2 gets cancelled, and 60 plus 20 is 80. And since we are finding work and we are multiplying the two dimensions, one dimension belongs to y-axis, that is force axis. The second dimension belongs to displacement axis, that is x-axis. So its unit will be Newton meter, because this 20 Newton plus 60 Newton, and this will be in meter, isn't it? So 2 gets cancelled, but here it is Newton and here it is meter. So we are left with 80 Newton meter, and this 80 Newton meter can be written as joule. So we have found the work done. So this is one of the important application. In thermodynamics also, we find the work done, since we write thermodynamic work done as thermodynamic work done. Thermodynamic work done. So this W is equal to PdV from V1 to V2. So this will be given by, again, this is area between pressure volume curve and the volume axis, isn't it? So this is the work done. So it's very simple now. Suppose a student skip this topic, integration and differentiation, and finally jump into the physics. So what happens now? He has to, or she has to remember various formulae. For example, work done is equal to area between pressure volume curve and the volume axis. Here work done is equal to area between force axis curve and the x-axis. There may be many formulae, but if you know the very basic concept, that if I write f dx, it means that it is area under the curve. If I write p dv, it means that it is area between pressure volume curve and the volume axis, isn't it? So these are the logic. Now if I write here, that is suppose, and there are many examples of this. Suppose if I write A is equal to dv by dt. So from here we get dv is equal to a dt, isn't it? Now if I integrate it both sides, this dv is equal to a dt. So since we are putting limits here, suppose at time t1 the velocity of the particle is u, and at time t2 the velocity of the particle is v. So observe, while applying the limits, है ना. Keep in mind, and you must be careful that here the term dt is being used. So here it is dt, that's why we put the limits in t, in the format t. That is, this is infinitesimal small change in time. So here we put the limits of time, that is from t1 to t2. Here, this is infinitesimal small change in velocity. So here we put the limits of velocity u and v. Also, they are interconnected, that at time t1 the velocity of the particle is u, and at time t2 the velocity of the particle is v, isn't it? So on solving it, we will get this is dv. So actually this can be written as 1 into dv uv. This can be written as, take a as constant, and consider I am saying this a is acceleration and I am taking here as constant. So if I take it as constant, then this a must come outside the integration, and inside you get left with dt from t1 to t2. So integration of 1 is with respect to v is v, isn't it? Listen, many students get confused that what is the value of 1 dx. So dear student, this 1 can be written as x to the power 0, because anything to the power 0 is 1. Now apply the formula x to the power n plus 1 by n plus 1. So this will be x. So integration of 1 is x. Similarly, here integration of 1 is v, because the integration is with respect to v. So don't get confused by this v and this v. This v is variable v representing the variable velocity, whereas this v is representing the final velocity. So here 1 is being integrated with respect to t. So here it will be t, and this will be from t1 to t2. So here v minus u is equal to a. Now put the upper limit minus lower limit. So this is, so what is v minus u? That is change in velocity is equal to t2 minus t1, isn't it? So what happens now in this expression? What happens if I don't take acceleration outside? Suppose this is 1 dv u to v, and this is a dt t1 to t2. So this expression will give change in velocity. Left hand side gives change in velocity, because it will come as v minus u. And what is v minus u? That is delta v, change in velocity. And this relation, are you observing? If you take y-axis as acceleration and x-axis as time, then this will be give area between acceleration time curve, area between acceleration time curve and the time axis. Now this is again application of integration. Are you getting? So what is change in velocity? Area between acceleration time curve and the time axis. Next, now let us have some examples. So far we have completed the theory part of this integration. Now let us apply those concepts or formulae while solving this. So this is, so starting solution, x cube. So on solving we get for using the formula x to the power n dx, using the formula that is x to the power n plus 1 by n plus 1. So power gets increased by n plus 1, and whatever will be in power will be in denominator. So x cube will be given by, this is x to the power 3 plus 1 by 3 plus 1, then limit. So this is minus 1 to 4. So this will be x to the power 4 by 4. Put the limits minus 1 to 4. Now what we do, we in place of x, first we put the upper limit and remain all things of expression as it is, put bracket, after that put minus sign, then in place of x put lower limit, that is minus 1 to the power 4, and all the things will remain as it is. So this will be 4 to the power 4 by 4 minus 1 to the power 4, even multiplier, even power. So this will be 1 by 4. So what happens, this is actually 4 to the power 4 by 4, it means that 4 cube minus 1 by 4. So this is 4 cube, 4 4 the 16, 4 the 64, minus 0.25, and this will be 63.75. So this is the answer, isn't it? 63.75 is the answer. Next is separating this. So this will be x, this is 1 to 2 minus 1 by x, limit is 1 to 2. So the integration of x is x square by 2, limit is from 1 to 2, minus the integration of 1 by x is log x, and the limit is from 1 to 2. So on in place of x, put upper limit. So this will be 2 square by 2 minus, put lower limit 1 square by 2. Then minus sign. So here we have log 2 minus log 1. So here this will be 2 square by 2 is 2 minus 1 by 2 minus log 2 is given, log 2 is equal to 0.693 minus log 1 is 0, isn't it? 0.693, this is 0.693 minus log 1 is 0. So this will be 2 minus 1 by 2 is 0.5, so this is 1.5 minus 0.693. So solve this value, this is homework for you, isn't it? So this is how we put the limits. Second is 1 by 2x plus 3, this is equal to log 2x plus 3 divided by 2. Since it is the multiplication with the variable x, so it will be divided, isn't it? As we have done in sin x plus b. Cos square x. So here we are not, listen, here we the limits are not applied, so here we put concept of integration c. Again here the limits are not applied, so whatever the result will get added by concept of integration. So this can be written as using the trigonometric formula, that is 1 plus cos 2x whole divided by 2, isn't it? So this can be written as integral 1 by 2 dx plus integral cos 2x by 2 dx. So on further solving, this 1 by 2 dx is, take 1 by 2 outside, so this will be 1 dx plus take 1 by 2, this is constant outside the integration, here this is cos 2x dx, and here 1 by 2, this is x, this is again 1 by 2, and the integration of cos 2x is sin 2x, it is sin 2x divided by 2, isn't it? Remember the formula cos of ax plus b, isn't it? So I input the constant of integration c. So this is the solution, x by 2 plus sin 2x by 4 plus c. Next, now here this is sin square x. So this sin square x can be written as 1 minus cos 2x by 2. Now put the value from 0 to pi. Now this can be written as, this is 1 by 2 from 0 to pi minus 1 by 2 cos 2x from 0 to pi. So this 1 by 2 take outside, so you are left with x, and the limit is 0 to pi minus 1 by 2, and the integration of cos 2x is again, this is sin 2x by 2, sin 2x by 2, put the limit 0 to pi. So here this will be 1 by 2 pi minus 0, put upper limit, minus put lower limit, this is 1 by 4, now put upper limit, that is sin 2, in place of x put pi, and this will be in place of x, if you put 0 then this will be 0. So this will be pi by 2 minus 1 by 4 sin 2 pi. So dear student, sin 2 pi is sin 360 degree, that is equal to 0, sin 0 is again 0, so this whole quantity is 0, so the answer is pi by 2. This is the answer, isn't it? So it is equal to pi by 2. Now next is GMM. So here it is the expression that comes in the last chapter of first part of class 11, that is gravitation. We have to solve this. Here G is the gravitational constant, universal gravitational constant, m is the mass of the planet, small m is the mass of the object. So these numerator, the three terms, that is G, M, 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 are constant. So we have, So we take these constant values outside integration, and here we are left with 1 by x square can be written as x to the power minus 2, and the limit is from infinity to r. So apply the formula x to the power n, that is x to the power n plus 1 by n plus 1. So here if I write x to the power minus 2, so this will be x to the power minus 2 plus 1 by minus 2 plus 1. So this will be x to the power minus 1 by minus 1. So this can be written as minus 1 by x, isn't it? So this is minus 1 and x to the power minus 1. So if you shift x to the power minus 1 from numerator to denominator, then power gets changed from minus 1 to plus 1. Hana, remind the lecture 1, that is the algebra chapter of the basic maths we have run there. So this will be minus 1 by x, isn't it? So gmm minus 1 by x, so I put the minus sign before gmm, and this is here 1 by x, limit is from infinity to r. On further solving we get this is minus of gmm, so this will be minus 1 by r minus 1 by infinity. So this will be minus gmm by r, and just 1 by infinity is nothing but 0. So this is the solution, isn't it? Now next, cos x. So integration of cos x is sin x. So the limit is from minus pi by 2 to plus pi by 2. So put upper limit, that is sin pi by 2, minus put lower limit, that is sin of minus pi by 2. So sin pi by 2 is 1, minus sin of minus pi by 2 is sine of minus theta. Remember, sine of minus theta is equal to minus of sine theta. It means that if I write sine of minus pi by 2 is equal to minus of sine pi by 2, and this is equal to minus 1. So sine of minus pi by 2 is equal to minus 1, that is minus 1, and this is 1 plus 1 is equal to 2. This is the answer. So what is this? This is having value 2. Next, a particle starts from rest with varying acceleration given by a is equal to 2 plus 3, isn't it? A is equal to, find the velocity of the particle at time t is equal to 3 seconds. So a is given as 2t plus 3. Since particle is starting from rest, it means that its initial velocity is 0, isn't it? And we have to find the velocity at time t is equal to 3 seconds. So let that velocity at time 3 seconds is equal to v. So what happens now? When particle moves some distance with this varying acceleration, its velocity gets changed from u to v. So we start this solution by a is equal to dv by dt, implies that this dv can be written as a dt. Now integrating both sides and applying the limit. So observe carefully. Here the term is dv, so here we put the limit of velocity. Here the term is dt, so we put the limit of time. But while applying the limits, you must keep in mind that these limits must correspond to each other. For example, particle starts from rest, that is initial velocity is 0, and this happens at time t is equal to 0. So when time t is equal to 0, the velocity of the particle is u, and that is also 0. When time t, that is at time t is equal to 3 seconds, the velocity becomes v. So this is how we put the limits, isn't it? So on further solving, the integration of dv, as we know that earlier we have done it, from 0 to v, and here we put the expression of a, that is integral 2t plus 3, 2t plus 3, and the limit is from 0 to 3. So this is v minus 0. Now integrating this, we will get 2t square by 2. The limit is from 0 to 3 plus 3t. The limit is from 0 to 3. So separate these terms. Integration of 2t, take 2 outside. Integration of t will be t square by 2. Put the limits. Here integration of 3 dt, take 3 outside. So integration of dt is t. Put the limits here. So here it is v. Now put the upper limit, that is 3 square. This 2 gets cancelled, na? This 2 gets cancelled. T square means 3 square, that is 9. And put the lower limit, it will be 0. Now here put the upper limit 3. So 3 3 is a 9. When you put lower limit, it will be 0. So v is equal to 18 meter per second. So velocity at time t is equal to 3 second is equal to 18 meter per second. So this is a practical application on based on the integration, isn't it? Now force acting on a particle is a function of position x, and force is given by x plus 2. So this force is given by x plus 2. Work done by this force if particle moves a distance of 5 meter along the direction of force. Initially the particle is at the origin. So initial position of the particle, let us suppose x1 is 0, isn't it? Final position, that is x2, is 5 meter, and since the particle is moving along the direction of applied force, isn't it? Particle moves a distance of 5 meter along the direction of force. It means that the angle between the force and displacement is 0. So we have the formula force Fs cos 0. So we have the formula Fs, that is force into displacement. But since here the force is variable, so we use the formula f dx from x1 to x2. So work done is given by, write the expression of force, that is x plus 2, and the limit is from 0 to 5. So integrate this. So this will be x dx from 0 to 5 plus 2 dx from 0 to 5. Integrating this, we get x square by 2, 0 to 5, plus this is 2x 0 to 5, isn't it? So this will be 5 square, 25 by 2, put 0, everything will be 0, plus 2 into 5, 10, put 0, 0. 25 by 2 is 12.5, 12.5 plus 10, that is 22.5 joules. So this is the work done by the particle. So the answer is, what is the answer? That is 22.5 joule, isn't it? Now next is, you can take a screenshot now. You can take a screenshot. So the next question is, find distance covered. This is speed and this is time. As we all know that v is equal to dx by dt. So here dx is equal to v dt, isn't it? Now if I integrate it, suppose at time t from t1 to t2, at time t1, suppose this is at position x1, you can say this is at x1, and at time t2 this is at position x2. So what is dx? This is x2 minus x1 is equal to integral v dt, that is from t1 to t2. And what is x2 minus x1? That is change in position, and change in position, if this is in along linear direction, so this will give the distance. So distance, and what is this v dt? This is nothing but area between vt curve and the x-axis. Area between vt curve and time axis. So here if we wish to find the distance, so so this is the graph. This is the graph. Here if we wish to find the distance, so from in the question, just one thing is given, that find distance covered, and there is a graph, and in graph there is some data are given, that is this is 4 second, this is 10 second, and this is 10 meter per second, this is meter per second. So what is distance? So we have to find the distance from time t is equal to 0 to t is equal to 10 second, because graph is starting from t is equal to 0 and ends at t is equal to 10 second. Are you getting now? So in question there is not given that from this time interval, within this time interval we have to find the distance, but it is understood since graph starts from 0 and ends at time t is equal to 10 second, and if you are asked to find the distance. So it is very clear that you have to find the distance from t is equal to 0 to t is equal to 10 seconds. So what is distance here, student? Distance is area between this vt curve and the time axis. So we have to find this area, that is area between this vt curve and the time axis, that is area OABCO. So what is distance here? Here distance is nothing but, here if I write distance, here if I write distance, so distance is nothing but, since distance is v dt from t1 to t2, so this is giving the area. So this is area OABCO, OABCO, and this is again forming a trapezium, है ना? So having two parallel sides, that is AB and OC. So the formula is given by, this is half sum of the parallel side, that is AB plus OC, multiplied by separation between the two parallel lines, that is BC. So on solving this, you will get 1 by 2 AB. AB is given by this value. So this value is 6 seconds. So this is 6 seconds plus OC is 10 seconds. And what is BC? This BC is 10 meter per second. 10 meter per second. So on solving this, 2 ones are 2 fives are, so this will be 6 second plus 10 second is 16 second multiplied by 10 meter per second. Second cancel, and this will be 160 meter. So this is the answer, isn't it? So if you know the concept, these such kinds of questions hardly takes 50 to 60 seconds. And if and those students who don't get the concept of differentiation and integration, then paper will appear as tough if such kinds of question comes in the examination, NEET examination. And those who have the concepts of integration and differentiation will enjoy such kind of questions, isn't it? So physics is enjoyable, dear students. So that's all for this lecture. Thank you. All the best.